Yes, hello everybody. My name is Dejan Dragic, and I'm the recent addition to the Phase 1 EMEA sales team. Today, I will speak to you about the topic of Phase 1 cameras in precision agriculture. Precision agriculture is quite complicated and still undeveloped totally field where we are combining different modern technologies in order to achieve better results and to optimize your yields. Thanks to the Phase 1 cameras, some new use cases in this field are being discovered, and during this presentation, we will try to go through the range of products, applications, and we will also show you what you can do with the application of Phase 1 camera together with the other sensors. So basically, we will start with the range of products, and Phase 1 has very diverse range of products. In the offer of Phase 1, you can find different kinds of lenses, such as homemade Phase 1 lenses, Rodenstock, Schneider Kreuznach lenses. They are enabling very big speeds up to 1/2050 seconds. They are manufactured with precision for eliminating image quality, performance, and very big durability. What is quite specific about Phase 1 lenses is the fact that you can make up to 500,000 shutter occlusions, and this is something what differs Phase 1 from the others in the market. They are available in the range of focal lengths from 23 millimeters up to 300 millimeters. Also, besides that, we are offering motorized lenses for UAV inspections where you can change the focus during the flight. Besides that, Phase 1 is also offering different range of cameras. In the offer, you can find cameras from 50 megapixels, 100 megapixels, 150 megapixels, 190 megapixels, and 280 megapixels. They are very cost-effective alternatives to the large format cameras. And in the offer, as you can see, you can find RGB and near solutions, and that is very important for the precision agriculture field. Thanks to the very good computing speed of Phase 1 cameras, there is a very good multiple camera synchronization. Also, all these cameras are UAV ready, and they are low weight and close. They are offering very easy integration with the UAV platforms. Also, connection is very good solved, and we are offering USB 3 or 10G Ethernet and XQD CF cards as a storage option. And besides that, Phase 1 is also offering iX controllers, where you can basically power and drive multiple cameras. It contains 2 removable SSD disks with the optional RAID system for data mirroring. It also offers you unlimited storage with multiple SSD drives. It comes with pre-installed iX Capture and Capture One. And also besides that, Phase 1 is also offering software solutions. And you can there see that, sorry, just a second. You can there see that the quality of the processing engine from the RAW and to TIFF is the best in the market. Also, there is an SDK for Windows, Macintosh, and Linux platforms. Data processing centers are also supported. We are offering also iX Link for real-time control via serial communication. And there is also option to get flight planning and flight management software called iX Flight. Yeah, what I mentioned already is that Phase 1 is offering 4-band solution, and that is very important for precision agriculture field. Thanks to the combination of 2 cameras, you are able to get RGB images, near image, SEER image, and also NDVI image as a result. Thanks to the camera calibration, 2 cameras, controller, and the software, you can easily play around with your data that is extremely very high resolution. And in the following few slides, I will try to show you what some of our partners are basically doing with these cameras, because as I already mentioned, Phase 1 cameras are helping people to explore new applications in precision agriculture field, because thanks to very high resolution, people are able to do something that they weren't able to do in the past. Next, as I said, there will be some applications shown. Some of the applications are basically plot-based rate assessment that our partners from Feno Inspect did. They are just using phase one cameras in order to process the data in the field and capture the pictures. And the trait assessment basically means visual evaluation of the plant's phenotypes. And right now it's being done mostly manually, but thanks to phase one cameras, now they can carry it together with AI based on phase one imagery, and that is saving quite a lot of time. And also, since it's being done usually manually, it's saving also high personnel demand and a lot of costs there. Basically, relevant plant characteristics now can be recorded together with pictures. And on the right side, we can see also one more example from US ASK, where they did the digital phenotyping with phase one cameras. In this slide, you can see drone-based ear counting. And on the right, there is a video of a drone in field flying in order to show you how it's being done. And thanks to, again, to this very high resolution imagery, you can do ear counting with AI. This is saving quite a lot of time and resources for everybody because, as I also said for the previous slide, it was done manually in the past, and now it can be done using AI. Next one is trait assessment in sugar beet. As I previously said, trait assessment is visual evaluation of the plant's phenotype. So we can see here how on the concrete example of sugar beet, trait assessment can be done, and we can see the results. And the results are really astonishing. And this basically presents the revolution in the field of precision agriculture. And our friends from PhenoInspect are doing a great job there. Yeah. Also, one of the applications that is also offered in the PhenoInspect offer is still counting sizing, semantic maps, homogeneity assessment, stress disease, weed monitoring, individual objects. And we can see that AI-based system is specialized in analysis of the plants and the generation of field status reports. It identifies both individual plants and weeds using RGB images from data obtained from drones using phase one cameras, of course. It takes some time in order to generate ground truth, but as we can see here, results that we are getting from this imagery is saving a lot of time and resources, and that's the point of precision agriculture. You know, the point is just to save resources. And besides that, we can see here that there is a combination of phase one cameras together with other cameras, where one of our partners implemented phase one camera in parallel to some hyperspectral cameras. And we can see that the results are offering natural color imagery that is very high resolution. And it enables you to cover very easily large areas in the field. Also, as a result, you can get sear imagery, and it helps you to do quite a lot of analytics right away, and it's delivered as a product when you are processing the data. Also, there is a vegetation vigor index, and we can see that in the combination of the cameras, when we are overlapping the results, data is still very high resolution, and this gives you much more possibilities in processing, because if you are trying to do any AI-based analytics, thanks to the very high resolution, you are able to perform it. Also, there is a leaf pigmentation index. It can be related oftenly with the leaf chlorophyll concentration. And also here we can see that in the overlap with the RGB and sear imagery from phase one camera, the results are very high resolution. And when you are processing it, it gives you much more possibilities because of this very high resolution. Yeah, next one is the leaf temperature index. It's very often related with the leaf water stress. And we can see here also that this high resolution imagery provides you very good results, and for all kind of image analysis, it's very important to have this because your results will be much better. And the next one is probably one of the most popular tree canopy height indexes. And on the picture here, we can see that blue color presents low values and red is extremely high values. And this is based on low resolution digital surface model. And on the next slide, we can compare it, how it looks when we generate it with the high resolution DSM generated from phase one imagery. And we can see that difference here is quite obvious. And the possibilities that you're getting from high resolution DSM are much bigger. Thank you for your time. And I would like to point out that unfortunately, precision agriculture field is still undeveloped totally, and it's developing and growing by the day. And I'm very happy to see that phase one partners and also phase one is giving a lot of efforts in order to educate also people about this field, because it's very important to think about our environment and try to develop new technologies in order to reduce the effects of chemicals that are being used in the field. And thanks to precision agriculture field, we can do that. And with all these applications that we saw into this presentation, we can see that new technologies are bringing some benefits. And thanks to them, we are not just saving time and resources, we are also reducing the amount of chemicals that are being used. And this is very good for also our future, because at the end, this earth will going to stay to our kids, and it's very important to have it safe. Thank you a lot for your time, and that's it from me. And please, if you have any questions, please feel free to reach me out at my email address. It's ddc@phase1.com. I'm open for all questions, and I will be very happy to answer it. Thank you.